Welcome to the WION Podcast. Today, we're doing a deep dive into something really mind-bending from the universe's earliest moments. We're talking about some very strange black holes.
That's right. Primordial black holes formed, right after the Big Bang. But these weren't your typical kind. We're looking at evidence suggesting some were incredibly tiny.
Tiny. How tiny?
Well, think about the mass of, say, a rhino, but packed into a minuscule space.
A Rhino-Mass black hole. Okay, that's...
Exactly. And the really weird part, they were supposedly supercharged, packed with immense color charge.
Okay, hang on. Color charge, you're not talking about red or blue, right?
Yeah.
This is physics speak.
Precisely. It's a fundamental property. Governs how quarks and gluons, the basic building blocks, interact via the strong force. Nothing to do with visual color.
Gotcha. So these rhino-sized things had a ton of this fundamental charge.
An extreme amount. So much so that they'd represent a totally new state of matter, something completely exotic.
And how would something like that even form?
Well, the theory goes back to the very first instant, like the first quintillionth of a second. You might have had these incredibly dense, tiny regions in the early universe plasma that just collapsed under their own gravity.
A quintillionth of a second. Wow. So they popped into existence then. Did they stick around?
Not at all. Their lifespan would have been incredibly short, like unbelievably short.
Gone in a flash.
Pretty much, evaporating in a fraction of a second due to, well, processes related to that intense charge.
Okay, so if they existed for such a tiny, tiny blip, how could they possibly matter? What impact could they have had?
That's the fascinating question, isn't it? Even though they were fleeting, their existence, brief as it was, might have left ripples. Researchers think they could have perhaps influenced the way atomic nuclei started fusing together back then.
Ah, nucleosynthesis, the creation of the first elements.
Exactly. That whole process was incredibly delicate. Even a slight nudge from these evaporating charged black holes could have subtly altered the balance of elements we see today.
So a tiny event having potentially huge consequences down the line.
That's the idea. It shows how sensitive the early universe was.
And I read somewhere this might connect to dark matter too. Is that right?
It does, yeah. It's another angle. People are looking again at primordial black holes in general as potential dark matter candidates. And even these short-lived, supercharged ones. Well, could their existence or evaporation somehow contribute to the dark matter puzzle? It's definitely back on the table for investigation.
So it opens up new ways to think about that mystery.
Absolutely. It widens the possibilities for what dark matter could be or what might have influenced its distribution.
So the big picture here is, even these incredibly strange Rhino-Mass supercharged black holes that basically vanished instantly, they might still hold clues about how everything, the fundamental structure of the universe came to be, and maybe even help solve dark matter.
That's the potential, yes. It really underscores how important those very first moments were, and how phenomena we can barely imagine might have shaped everything that followed. Even the briefest events can leave a detectable imprint.
Amazing stuff. Really makes you think about those first fractions of a second.
Definitely. It's a very active area of research.
Well, that's all we have time for on this deep dive. Stay tuned for more such intriguing stories to come on the WION Podcast.